our final talk tonight, guys, and then we can go to the pub. Damien, thank you very much.
Thanks. Okay, I'm going to talk about applied computational thinking, trying to shove 45 minutes into 20, so you can all go to the pub or home. Understanding the world with computers, navigating between abstract and concrete representation. Who am I? I've done this school in Paris, Gobelin, where I learned to work with graphic designers. Then learned the ropes of advertising at Unit 9 and John Variable. I'm tech lead, creative dev. I might be kicking some open doors right now, but I use code as a medium for something expressive rather than purely functional. If I have to put some labels on what are my interests, generative art, data visualization, computer graphics, and all the kind of related topics that revolve around that. Generative art, quick definition, produce artworks by building very often a rule-based system and by delegating some part of the decision-making to a computing unit. I'm going to try to use this input-output analogy quite a lot, where for generative art, we have instructions as input and output. We tend to forget sometimes, but we can have a lot of different things, music, sculpture, anything. I'm quite fascinated by these people in the 60s that were already doing that. Manfred Mohr, Vera Monar, Georg Ness, Friedrich Nacke. If you Google them, you get plenty of good inspiration. And nowadays, well, we kind of do the same thing in the generative art, this kind of world, but it's much easier with all the computational power that we've got now. So that's why I'm really impressed by these people in the 60s that were doing that, like with very low-end machines for today's standards. Second topic, I'm interested in data viz. When I say data viz, I'm not talking about infographics, bar charts, Excels, etc., etc. In its simplest definition, I'm talking about the graphical representation of information where we have data as an input and as an output, same as a generative art, a lot of different things, sculpture and drawing, you name it. If you're more interested in this side of the data visualization, I can recommend, for instance, the Data Stories podcast with Maurice Stefano and Enrico Bertini, where for the past 4 or 5 years, they've been interviewing people discussing different topics. Marcin, our founder, was on this podcast 2 weeks ago, so go check it out. Other project that really seems to transpire what data visualization can be, the Market Cafe magazine, simple zine that present different topics, interview people to talk about these topics. And projects that, for me, are quite representative of what data viz can be. And I don't have internet, but I have it open here. Magic trick. Okay, I'm not going to be able to show you, but this visualization of the song Space Oddity by David Bowie, where the different parts of the songs, the melody, the lyrics, were printed on LPs. So that's one interesting piece of data visualization. And the other one I want to mention is Dear Data by Stephanie Posavec and sorry, I forgot the name of the other person. It's on my slide. They were sending, Georgia Lupi, they were sending each other postcards the old school way through the mailbox between the US and the UK, I think, where they were visualizing something about their week, like how many times did I laugh this week, how many times did I hear my partner snore, this kind of stuff, and just sharing this little piece of data. So as you can see, database can be a lot of stuff. I'm interested also in computer graphics, the pipeline, the tools, the techniques. That means I know vaguely what all the acronyms at the bottom of the slide means. We love acronyms in computer graphics, I guess. Yeah, all of these interests, they lead me to do some open source projects and also projects on my own. I'm going to briefly talk about two of them. This one that I've done, my partner, it's Exacoria in this time of climate crisis. For us, coral was very representative of the issues, so we tried to bring back some colors and playfulness to it with this simple WebGL experiment, where we also have webcam input, where you can show your hand and play a bit with the coral using a hand tracking model. It's cool. And last year I also was participating in the Winter Light Festival in Reykjavik, where we had the opportunity with other artists to show something on this building, the Harpa Concert Hall, in the center of Reykjavik. It's a huge building, as you can see. So it was very interesting to work with, so all these slides are LED strips, and it was very interesting to work with this opposition between the size of the building and the tiny resolution we had to work with. It was 77 by 15 pixels, something like that. So yeah, that was interesting for me. So yeah, doing that, I've been working for some time now, and I think it was a good time for me to reflect on what I was doing. I tried to pinpoint and find the term, and computational thinking was kind of on point for me. It's a term that has been used mainly in academic circles, also in the US to encourage the teaching of computers earlier in schools, but I think it's a bit reductive of the idea and what it can be. This idea and its premises, they've been around since the 50s, since the computers took different names, combinatorial thinking, algorithmic thinking. We extended also, J. David Bolter extended the opposition classical versus modern men and pushed toward the Turing man, human I'm going to use. But whatever the naming, these ideas, they tend to emphasize the value of coding concepts and more generally the use of computers as a mental tool to understand and solve all kinds of problems. So to sum up, it's a general purpose mental tool. Should be noted that it's just a way of thinking and shouldn't, supersede any other ways of thinking. All other theories, they should all work together ideally. So the term has been revived a bit in 2006 by Janet Wing. She's a researcher for Microsoft and teacher as well. She defined it as the thought processes involved in formulating problems and their solutions so that the solutions are represented in a form that can be effectively carried out by an information processing agent. What a mouthful, but that's englobing all of what it is. So for her, it's basically correlating how computer scientists approach problem. And I think this is a term that might be used in our information age. It's keep going to be used more and more. We even have effort to try to vulgarize the term. Like John Maeda released a book called How to Speak Machine, Computational Thinking for the Rest of Us, that I invite you to check out. One of the problems that you have when you think about thinking, you tend to get a bit detached from your reality. So I'm trying to put something a bit more tangible on that. And when I say apply computational thinking, I'm referring to this ability that we have to think more like computers and make them think more like us. One perfect example of this for me is AI in neuroscience, where on one side we get deep learning that is somewhat inspired by our understanding of the brain. We use the same terminology in neural networks. On the other end, got AI that helps neuroscientists interpret huge data sets, because from what I understood, the process so far is mainly putting electrodes on people's head and trying to make sense of whatever comes out of the data. So here, like, machine learning really helps solving this problem and cracking the neural code, like what triggers this movement, for instance. So yeah, this teamed up relationship between us and the computer, it's continuously opening new world of possibilities, and we tend to go from solving problem to having problem solved, which is very interested to, enhance ourselves in some ways. If you can just quote Andrew Enk, I'm not sure I pronounce it right, but if you're trying to understand AI's near-term impact, don't think sentience, instead think automation on steroids. That pretty sums up what I think. So in some form of machine learning, the unsupervised learning, we delegate some part of the process to this computation black box here. And it's cool, but I'm trying to understand what I'm doing. So for me in my job, I think it's more problem solving with computational help, where I got a problem, I'm trying to destructure it to reach a solution. If I go even deeper, what I concretely do is build systems with parameters where I do some abstraction and some representation in order to reach an expression. And this process, it naturally triggers interesting question, as in much abstraction is too much. What do I do if I don't know all the parameters? And is my expression biased? Am I inclusive enough? What is the context, social, economical, cultural context of my expression? In reality, it's a bit more of a loop between abstraction, automation, analysis, and that's really the core process, I think, of what I'm doing. And yeah, I keep looping on this until, well, we're satisfied or we reach the deadline sometimes. And that's what we do at Viable, I think. Sums up pretty much what we do. Because we work with brands, research group, organization on new ways of experiencing data, and we try to bring that solution to connect all of that to human sensitivity. How we do it with data visualization, research and development, generative and data art, and bespoke design tools. I'm going to try to speak about the process, and as you might have got from now, it's data is the clay of what we sculpt, basically. We hear a lot about the big data and all this stuff, but we still have to remind ourselves that it's just a set of organized qualitative and or quantitative variables. And for us, these variables, we think it's not just, they should be experienced, not only counted. They have something more than just, they're something more than just numbers. I'm going to quote Sherlock Holmes: "It's a capital mistake to theorize before one has data." And that's the starting point of our process, usually, where we try to unfold the data with some research and development and some more classical representation that helps us see the data and find the patterns in them. And so yeah, we do that computational thinking. We build system, we break them, and yeah, keep doing that. And usually it takes form of generative and data art. And we think it's a starting point for discussion. It doesn't have to be obviously readable, and that triggers different medium for us: website, installation, screens, etc. So I'm going to try to present a bit two pieces of work. The first one is inflows, outflows, which shows 10 million data points of immigrations pattern in the Middle East between 2006 and 2014. So this first visualization really shows first important element that happened in 2008, 2009, where we see a bit less white after the global economic crisis. And this data set has been represented in these ways. For instance, on the left, it's literally inflows and outflows of people coming and exiting the countries. On this side, we get more colors because we took into account the level of education of these people coming in different countries of the Middle East. Second project I want to talk about is the IBM Technology Garden. Basically, the video plays. No. Yes. IBM is collecting a lot of data at the tournaments of Wimbledon. So we got the opportunity, thanks to GPJ, to work with IBM and do this screen installation on site during the tournament, where we visualized some of the data as flowers, data flowers. So for instance, this was the website's data. This was one particular match where we see different sets creating different branches, and everything was controlled by an iPad on site, where we had the opportunity to get in real time the latest scores, and people could just come to the booth and see all of these different databases. This last one is just the weather, where it was blooming more or less depending on the weather conditions. And I think I stole this from one of previous talk from Martin. What I cannot create, I do not understand, because it resonates a lot with what I'm going to talk about next, which is the creation of our own tool nodes. So I have a bunch of slides that I'm probably going to need to skip, but just to give some context, half of the human brain is devoted directly or indirectly to vision. Half, it's a lot, it's huge. So that's why we think visual programming is a good thing, and it helps solving some of the problems that you have when you write code. Quickly, how many of you have ever used a nodal interface like this? Cool, so I'm not completely lost here. The motivation of this project that started 2-3 years ago was started with Nick and Martin. It was, as I said, moving from a mental map to a visual map using the web, and all the tools at the time had limitation. Instead of detailing all of the features, I'm just going to try to switch to the actual thing and show you how it works. I need some jazz music here. Okay, so what we're going to try to do tonight, if it works, I'm not connected to the internet, so I don't know if it's going to work, but I'm going to try, is to build a particle system with some post-processing. Okay, so here I am in the interface of nodes, where on this side here, I got a graph that is empty for now. I got a scene where I'm going to visualize what I'm doing, and an inspector where I can change parameters. First of all, I'm going to need a context, which is a node that's going to help me create WebGL context so I can draw 3D stuff in it. I can have some parameters on this node that I can change. So for instance, this parameter helps me resize the context to something more standard HD, which is nice when I need to save screenshots, for instance. How do I save screenshots? I just connect previous nodes, and this node is just taking the current state of the canvas and exporting it as an image. Not going to do that, but just to show you quickly. So I'm going to need to build a particle system and add some post-processing on it. So how do I do that? I first render a 3D scene, and then I'm going to render some effect on top of it and merge the two of them. But for my application to work, I'm going to need to have some time, keep track of the time, so how much time has elapsed since the beginning of the application. Then, because it's 3D, I'm going to connect a camera. I know it's boring because you don't see anything on the screen yet, just nodes, but getting there. We can also build custom nodes because this is what we're trying to do. It's with these nodes. It's not just things that you connect, it's modules, pieces of code that you want to customize yourself and really dive deep into what they can do. It's just JavaScript, so you do whatever you want, you connect everything. And what I'm going to do now is basically trying to get different outputs from a callback. So if you've used React before, it's kind of the same thing where we get props that are shared between nodes that are going down from top to bottom. And we got a system of callbacks that help us pass the props in between the nodes. And for instance, how do I do that is I create what we call a port, which is by doing this, node triggering. And I'm going to listen to an on-trigger callback event. And then I have another port, which is trigger out, which I'm going to call, which allows me to continue down the data flow. I'm actually going to do two of them, so I can show you a simple trick. It's going to allow me to call this first function, so I'm going to draw the particles, and on top of them, I can also draw a GUI that I have already ready. Here you go. So how bad is this doing? I can't see. 59 for now. Okay. Right. Let's do the interesting stuff. We need to render to a texture when we do post-processing first. So I'm going to connect this. I have a particle system that is already ready. I'm not going to type this right now. So, templates are useful. And this needs a texture. So with this specific node, I'm going to just load an image and create a texture on my WebGL context. So I'm going a bit fast, but I'm running out of time. So I can duplicate this, add another texture for everything to work. And there you go. You have a particle system going full screen, so you can see, maybe? No, you don't. So yeah, it's a bit boring, so I'm going to try to make it more interesting with post-processing. And how do I do that? I'm going to have to render to a screen. So I'm going to render first all of that into a texture, and then I'm going to add some bloom on top of it. I'm adding a threshold node so I can control a bit more the bloom. And what I do is I take the texture and I send it to the bloom. It's going to do some magic here, and I'm going to need to add basically the first screen you've seen before and the bloomed texture. So I'm getting the scene rendered twice, and so I'm mixing the two basically, and I'm trying to render to the screen. Great, didn't change much, did it? So for that, these ports, they're not just the connections between the nodes, they're also the parameters, so I can basically send different values for my nodes, and this, for instance, is going to change the intensity of how well the two are going to mix. And I've got this threshold. I'm clicking on this publish, so I can, when I go full screen, isolate these two ports specifically and play with them. So the threshold, here we go. I'm going to let basically a bit more of the bloom pass here. And the intensity of the mix is helping me visualize how it was before, after. There you go. Quick particles in 5 minutes. Bit pressed by time, so I'm gonna skip, finish, give you some takeaways before you go back to your loved ones or the pub. Take time to feedback and reflect on your practice. Feels good. Stay curious, keep building knowledge, and build systems to understand the world better. Thank you.
Nice one. Thank you, Liam. Not Liam. Damien. Thank you.
Welcome.
Any questions, anybody?
Where is the pub?
That's coming. We got a couple over there.
Hey, so that was really interesting, and Nodes looks awesome. Do you have a sort of rough release schedule for betas or public? Is it like this year, next year?
I have a very simple answer. No. But we're working on that. We've sent it to a few people so we can get feedback and really work with these people so we make it better for a broader audience in some ways.
Thank you.
Do we have another one at the back there, or did I imagine that? Any more for any more? All right, guys. Please put your hands together for all our speakers.